So now we turn our attention to the specification of causal reliable broadcast. So our module is causal order, and the instance is CO. And we have the usual events: a request event to broadcast a message M, and an indication event that delivers the message M from the source. And the main property we have, we call it causal broadcast. And it says if a process PI delivers a message, in this case we call it M1, then PI must have delivered every message causally preceding M1 before M1. So here is our property, as we just said. If you deliver a message M, then you should deliver all causally preceding message before that. So that is our property. The question is this property is useful by itself? Is it sufficient? And if so, how it can be satisfied? So this is a question. The answer to this question is that this property is a safety property. And a safety property can always be satisfied by refraining to do anything. So, which would mean we can satisfy this by never delivering a message. So it is not useful by itself. We have to complement this property with other properties. Now, the next question is, we could have defined this causal broadcast property in a different way. One way that is actually very intuitive and everybody would have chosen this way instead is a definition that I have in CP prime. What does CP prime says? It says if a process Pj delivers M1 and M2, and M1 causally precedes M2, then Pj must deliver M1 before M2. So now we have two properties. The CP property that says if we deliver a message, we should deliver every preceding message. And here is the other way to define the property. So what is the difference and which one is more appropriate? And that is what we are going to discuss now. So we have these two properties here, CP and CP prime. And we are asking ourselves, what is the difference? For example, does CP implies CP prime or CP prime implies CP? We will show the difference by discussing two scenarios. Scenario that we call A and another scenario that we call B. So these are execution scenarios. So in the first scenario, we have a violation of CP and CP prime. So let us look to this. So here is a situation where M1 causally precedes M2, which causally precedes M3. But here we have a delivery of M2 before M1. So let us see now how they violate. So CP says if you deliver some message, in case this message is M2, then all preceding message should be delivered before, and therefore this scenario violates the delivery because M1 is delivered after. And what about CP prime? CP prime says if we deliver both M1 and M2, and M1 is before M2, then we should have M1 before M2, but that's not the case. This scenario violates both definitions. But look now to the next scenario, the scenario B. And in the scenario B, the message M is sent, but it is never delivered to P3. So the message is never delivered to P3, but it is delivered to P1 and to P2 here. So this scenario violates CP. Why it violates CP? Because we have a situation where message M2 is delivered everywhere, but M1 is not delivered at P3. But this scenario does not violate CP prime. Why is that? If you look to CP prime, the precondition here is not satisfied. So if a precondition is not satisfied, then CP prime is valid as a whole. So, and why the precondition is not satisfied? Because we do not deliver M1 at P3. So we can conclude the following. It is the case that whenever we have CP satisfied, then CP prime is satisfied. But we can have a situation where CP prime is satisfied, but it is not the case that CP is satisfied. And this is a scenario B. In the scenario B, we satisfy CP prime, but we do not satisfy CP. So our conclusion is that indeed CP implies CP prime, but not the converse. So in a sense, CP prime is a stronger condition. It talks also about the non-delivery of messages. For example, in this example, the message M1 that was not delivered to P3. So now let us look to the complete specification of reliable causal broadcast. We need the CP property, but we also need the properties of regular reliable broadcast, which is the validity, the no duplication, the no creation, and the agreement property. Once we have these, then we have a complete specification of the causal broadcast abstraction. We can move to uniform reliable causal broadcast by using instead the properties of a uniform reliable broadcast, URB1 to URB4 with the uniform agreement. This actually gives us an idea, which is while we are trying to implement now reliable causal order broadcast, CO, we can use reliable broadcast for this implementation. And while we are trying to do a uniform causal order broadcast, we can use the uniform reliable broadcast implementation. And that's what we are going to do in the next units.